Victories of the day, March 30th. 1. 1842, the first use of ether as a surgical anesthetic, medicine. On March 30, 1842, Dr. Crawford Long performed the first surgical operation using inhaled diethyl ether to render a patient unconscious during a tumor removal. Before 1842, surgery was a traumatic and agonizing process. Patients were physically restrained, and many died from surgical shock caused by the intense pain. The system utilized the chemical properties of ether to depress the central nervous system, temporarily blocking the transmission of pain signals to the brain. This shifted clinical medicine into the anesthetic era, proving that the human body could be chemically turned off and safely restarted, allowing for complex invasive surgery. This achievement redefined the ethics of patient care, transforming the operating room from a place of last resort into a controlled environment for healing. 2. 1858, the proposal of the chain structure of carbon, organic chemistry. Archibald Scott Couper submitted his paper proposing that carbon atoms could link together in long chains, a milestone in molecular topology. Prior to this, scientists knew the atomic ingredients of organic molecules but had no model for how they were physically connected in space. The system utilized the concept of atomic valence, showing that carbon atoms have 4 bonds that allow them to form stable, complex rings and branches. This shifted chemistry from a study of recipes to a study of architecture, proving that the physical arrangement of atoms determines the properties of a substance. Couper's work provided the foundational math for polymer science, enabling the future creation of everything from synthetic rubber to modern plastics. 3. 1867, the mathematical finalization of the Alaska Purchase, Geodesy. On March 30, 1867, the Treaty for the Alaska Purchase was signed, launching one of the largest geodetic surveying projects in history. Prior to 1867, the subarctic regions were a cartographic void with no precise measurements of the magnetic north or the true curvature of the Earth in high latitudes. The system utilized triangulation and astronomical positioning to map 586,000 square miles of territory, accounting for the Earth's ellipsoid shape. This shifted geology and mapping toward global coordinate systems, proving that standardized mathematical grids were necessary to manage resources on a continental scale. This project established the primary datasets for Arctic research, helping scientists understand the rate of glacial movement and tectonic shifts in the North Pacific. 4. 1889, the opening of the Eiffel Tower, materials engineering. On March 30, 1889, the Eiffel Tower was completed, serving as a massive laboratory for wind load engineering and structural physics. Prior to 1889, tall buildings were made of heavy stone and were limited by crushing weight. Engineers did not know how to build thin, lightweight structures that could survive high-altitude wind shear. The system utilized puddle iron in a lattice design, where the math of the empirical curve ensured that the wind's force was directed straight down into the foundation. This shifted civil engineering toward dynamic aerodynamics, proving that a building's primary enemy at great heights was not gravity, but the pressure of moving air. The tower was saved from demolition because it became a vital radio antenna, proving that massive structures could serve as nodes for global telecommunication. 5. 1934, the first flight of the Sikorsky S42, aviation engineering. The Sikorsky S42 flying boat made its first flight, a milestone in long-range transoceanic aeronautics. Prior to the S42, airplanes lacked the fuel capacity and structural lift-to-drag ratio to cross oceans. International travel was restricted to slow-moving steamships. The system utilized flush-riveted wings and 4 synchronized engines to provide the first reliable 2,500-mile flight range without needing land-based runways. This shifted global logistics toward airlink connectivity, proving that heavy aircraft could utilize the ocean as a universal runway. This aircraft established the first regular international airmail routes, shrinking the communication latency between continents from weeks to days. 6. 1939, the first flight of the Heinkel He 176 rocketry. On March 30, 1939, the Heinkel He 176 became the first aircraft in history to be propelled solely by a liquid-fueled rocket engine. Prior to 1939, all flight relied on internal combustion engines that needed oxygen from the air, meaning planes could not fly in the vacuum of space or the thin upper atmosphere. The system utilized hydrogen peroxide decomposition to generate thrust, proving that a vehicle could carry its own oxidizer and move independently of the surrounding air. This shifted astronautics from theoretical science to propulsion reality, proving that liquid-fueled rockets were the viable path for space exploration. The data from these flights provided the foundational thermodynamics for the engines that eventually powered the Apollo missions to the Moon. 7. 1954, the opening of the Yonge Street Subway, urban engineering. Canada's first subway system opened in Toronto, marking a milestone in subterranean transit physics and cut-and-cover construction. Prior to 1954, urban centers were physically clogged by surface traffic, elevated trains were loud, vibrated buildings, and blocked sunlight. The system utilized reinforced concrete tunnels built beneath street level, using electrical DC traction motors to move thousands of people per hour without surface interference. This shifted urban planning toward multi-layered cities, proving that the subsurface of a city was a usable third dimension for high-speed mass transit. This project pioneered vibration isolation techniques that allowed high-speed trains to run inches away from building foundations without causing structural damage. 8. 1982, the completion of the STS-3 mission, Materials Science. On March 30, 1982, the Space Shuttle Columbia completed its third mission, proving the Thermal Protection System, TPS, could survive extreme re-entry multiple times. Prior to the shuttle program, spacecraft were ablative, meaning their heat shields burned away and were destroyed during a single re-entry. The system utilized silica fiber tiles that could withstand 1,260 degrees Celsius without melting or transferring heat to the aluminum skin of the ship. This shifted materials physics toward refractory reusability, proving that a vehicle could endure the plasma of re-entry and return to flight within weeks. This mission confirmed that ceramic engineering was the key to making space travel economically sustainable through the reuse of flight hardware. 9. 2010, the high-energy beam record at the LHC, particle physics. The Large Hadron Collider achieved its first world record 7 TeV collision on March 30, a milestone in subatomic fragmentation. Prior to this, physics was limited by the energy ceiling of older accelerators. We could see the existence of particles, but we couldn't create the heat necessary to see the Big Bang conditions. The system utilized superconducting radio frequency, SRF, cavities to kick proton beams to nearly the speed of light before colliding them. This shifted quantum theory toward experimental cosmology, proving that we could physically recreate the fundamental forces that existed at the very birth of the universe. These collisions allowed scientists to begin mapping the Higgs field, providing the experimental proof for how particles in the universe acquire mass. 10. 2017, the first relaunch of a flight-proven rocket, aerospace economics. On March 30, 2017, a previously flown SpaceX Falcon 9 rocket successfully launched and landed a second time, a breakthrough in structural integrity analysis. Prior to 2017, the aerospace industry believed that the thermal stress of re-entry made an orbital rocket a single-use tool, similar to a firework. The system utilized titanium grid fins and Pike-X heat shielding to survive the 1,600 degrees Celsius re-entry environment before landing vertically. This shifted space logistics from disposable hardware to aviation-style operations, proving that rockets could be refurbished and reflown like airplanes. This achievement dropped the cost to orbit by millions of dollars, enabling the current era of mega-constellations and affordable satellite research. 11. Scientist of the Day, Crawford Long, 1815 to 1878. Crawford Long is the dedicatee of March 30 for his mastery of biochemical engineering. He was the first to realize that a chemical could safely interrupt the consciousness of a human being for medical benefit. Before his work in 1842, surgery and torture were often indistinguishable. He moved medicine away from brute force speed and toward precision procedure. The system he pioneered relied on the inhalation volatility of ether, allowing the dose to be controlled through the patient's breath. His legacy is the modern anesthesiology department, turning the most terrifying moment of a patient's life into a quiet sleep, and allowing surgeons the hours of time needed to perform life-saving organ repairs. Victories of the day, March 30.